let's use the definition of the derivative, which is the limit as h goes to 0 of f of x plus h minus f of x over h to find the derivative of the square root of x function. So in our definition, we have to figure out what f of x plus h is. So f of x plus h requires us to replace x with x plus h. And so we get the square root of the quantity x plus h. Those parentheses aren't doing anything because the square root symbol itself acts like the grouping symbol. Okay, so this does not simplify. The square root of a sum, the square root of a plus b, is not equal to the square root of a plus the square root of b. You can just check that with numbers. The square root of 2 plus 2 is, on the one hand, it's obviously the square root of 4, which is 2, but that is not equal to the square root of 2 plus the square root of 2. This is approximately 1.4 plus 1.4, which is 2.8, not 2. So you can't break apart a square root and a sum. You can break apart a square root if it's multiplication. The square root of AB is the square root of A times the square root of B, assuming that A and B are both positive. Okay, so upshot here from all this discussion is that our f of x plus h does not simplify in any way, and so we are just going to put this quantity here where it says f of x plus h, and then minus f of x, and then over h. So in order to resolve this limit, which is a 0 over 0 limit, as h goes to 0, you're going to get square root of x minus square root of x on the top, which is 0, and of course 0 on the bottom. So in order to resolve this, we use the conjugate radical. Conjugate radical. And that's the square root of x plus h plus the square root of x. It's the exact same square roots with the opposite sign in between. So write down the two square roots with the opposite sign. Now our goal is to cancel h on the bottom. So on the bottom, we don't want to distribute the h. We would just have to factor it back out if we did that. So let's just leave it separate and indicate the multiplication by just writing these things next to each other. So there we are. There's our denominator, h times the conjugate. And now on the top, we have to multiply these conjugates. And the whole point of conjugates is that they multiply together nicely. And in this case, we have a minus b in that form in the left fraction, and in the right fraction, we have a plus b. And then the difference of two squares formula says a minus b times a plus b is a squared minus b squared. So what goes here is a squared minus b squared. Now what are they? What is a squared? A squared, the square removes the square root, and we get x plus h. And then what is b squared? B is the square root of x. B squared is x. Now let's subtract. On the bottom, we just have to copy all this. On the top, subtracting gives us h. X minus x is 0. So we're just left with h. And now we can cancel h over h. We cancel that h, we're left with the 1. And when we cancel this h, we're left with the conjugate. And so this limit is the limit of 1 over the conjugate radical. That plus h is under the square root. Notice the plus h is under the square root every time. Okay, and this limit, plug in 0 for the remaining h. Plugging in 0 for h, we get square root of x plus square root of x. And so the final answer can be written as 1 over 2 times the square root of x. And so we see that the derivative with respect to x of the function square root of x is 1 over 2 times the square root of x. The square root function is very important. It comes up frequently, mostly because of the Pythagorean theorem. If you have a, b, then the hypotenuse, for example, by the Pythagorean theorem is the square root of a squared plus b squared. So because of triangles, square root and a Pythagorean theorem, the square root function comes up a lot. Let's have a look at the graph of the square root function. Y equals the square root of x is the top half of a sideways parabola. That parabola being the parabola x equals y squared, which goes like that. If you take the positive square root of both sides, you get this. The other half is y equals negative square root of x. Okay, so the top half of this sideways parabola contains the point, if x is 4, then y is the square root of 4, which is 2. So there's the point 4 comma 2. It's on this curve, and we want to know the slope of this tangent line. The slope of the tangent line at this point is the derivative evaluated at 4. The derivative tells us the slope of the curve, and it's a formula for the slope of the curve, so you have to input into the formula the x coordinate of the point of tangency. So that was 4. And the derivative formula is here, so f prime of 4 is 1 over 2 times the square root of 4, and that's 1 over 2 times 2, so that's 1/4. So this line has a slope of 1/4. Clearly it's a positive slope. Just from the picture, it's going uphill from left to right, so positive makes sense, and it's not very steep, so 1/4 makes sense from that perspective as well.